Hello and welcome students to the class of Business Statistics. So in the last class we were discussing about some basic applications of business statistics which we can apply in corporate companies very easily. Now, today we are going to discuss about some examples how companies use statistical tools to analyze something from the data in their companies. Okay, so many companies across various industries leverage business statistical tools to gain insights, make informed decisions, and enhance their operations. Here are some examples of companies and how they use statistical tools. Firstly, let's discuss about the Amazon. So Amazon uses advanced statistical models to analyze customer browsing and purchasing behavior. This data-driven approach helps them recommend products, optimize supply chain operations, and forecast demand. So just for example, whenever you're surfing on the internet and you want to shop something, so you just type in the Google that you have to purchase this particular product, and automatically after some time these shopping apps will give you some kind of uh, observations or some kind of advice that purchase this or recommendations, I can say. Okay, so how is this happening? So basically whenever you are browsing something, these shopping apps just take your history or historical data and then recommend you the same products, just like Walmart employs statistical analysis for inventory management and demand forecasting. By analyzing historical sales data and trends, they can ensure that products are available when and where customers need them. Then Google utilizes a statistical algorithm for its search engine ranking system. These algorithms assess the relevance and quality of web pages to provide users with most accurate search results. Then Netflix employs recommend algorithms that rely on statistical methods to suggest movies and TV shows to its subscribers based on their viewing history and preferences. Tesla. Tesla collects data from its electrical vehicles to perform statistical analysis on vehicle performance, battery efficiency, and predictive maintenance. This data informs product improvements and service offerings. Procter and Gamble. So P&G uses statistical tools for quality control and new product development. They conduct experiments and statistical analysis to optimize products formulations and manufacturing processes. Now, I can say each category or each topic has its own limitations. So statistics also having some kind of limitations. Let's discuss that. Firstly, data quality issues. Statistics heavily depend on the quality and accuracy of the data. If data is collected with biases or contains error, it can introduce significant distortions into the analysis, potentially leading to misleading results. So, whenever you are collecting any data through any kind of survey, you should check that data to be collected in with respect to the objective of the survey. If the data you are collecting is not relevant or if there is some kind of biasness, then definitely your results are misleading. Okay, your result will not be accurate. Second is sampling errors. The size of the sample used in statistical analysis can impact the accuracy of results. A small sample may not be representative of the entire population, leading to skewed conclusions. The method used to select a sample can introduce biases. For instance, if a non-random sampling method is used, it may not accurately represent the population. Third one is assumptions and simplifications. Statistical models often make simplifying assumptions about the data. If these assumptions do not hold in reality, the results can be misleading. For example, linear regression assumes a linear relationship between variables, which may not always be the case. Then causation versus correlation. So, statistics can establish correlations between variables, but it cannot prove causation. Causation requires additional evidences and experimentations. Then, historical data. Statistics often rely on historical data, which may not accurately predict future events, especially in rapidly changing environments or markets. Then, limited scope. Statistics can only analyze data that has been collected. It may not account for factors that were not measured or considered, potentially leading to incomplete analysis. Seventh is human judgment. Interpreting statistical results involves human judgment. Different analysts may interpret the same data differently, leading to subjectivity and potential bias. Overfitting. When fitting complex models to data, there is a risk of overfitting, where the model captures noise in the data rather than true patterns. This can lead to poor generalism or poor generalizations of new data. Ethical and privacy concerns. Collecting and analyzing data may raise ethical and privacy concerns, especially when dealing with sensitive information. These are some limitations of statistical data. Now, the next one is classification of data. Till now, we were just discussing about the statistics, like what is the statistics, how statistics is used, what are the applications, what are the limitations. Next, we will discuss about data and the classification of data. Let's start with the definition. So, data can be defined as a systematic record of a particular quantity. It is the different values of that quantity represented together in a set. It is a collection of facts and figures to be used for a specific purpose, such as a survey or analysis. When arranged in an organized form, uh, can be called informations. Now, data can be classified on the basis of four criteria. First is geographical, chronological, qualitative, and quantitative. Let's start with geographical data. So you can just bifurcate your data, or I can say classified your data area wise, such as states, towns, country, etc. Or it can be directions. Just for an example, here in the box an example is given. In the left side, region are given like central India, west, north, east, south, and then areas in hectare. So you can just bifurcate your data in on the basis of geographical. Then chronological. Some data can be classified on the basis of time and arranged chronologically or historically. Data on production of food grains in India can be classified as shown below, like in a chronological way, just like year wise, like 1990 to 91, then 91 to 92, 92 to 93, and so on. So you can just bifurcate your data if you're collecting the data from past time. Okay, so with respect to time, you can just bifurcate your data. Then qualitative data. Now, qualitative data cannot be measured in the numerical way. It can only be measured in some attributes, or I can say some characteristics which are depend upon the quality. Some data can be classified on the basis of attributes or characteristics. The number of farmers based on their land holdings can be given as follows. Just for example, types of farmer, numbers of farmers. So basically types of farmers, there are three types: marginal, medium, and large. Then how many number of farmers belongs to that particular category is already given in the right, like 907 marginal farmers, 1041 medium farmers, and 1948 large farmers. Then qualitative has two categories. First is simple classification, then second one is manifold classification. So first one is simple classification. In simple classification, the basically the population is categorized only in two parts. Only there is one layer. Like population is bifurcate in literate and illiterate. It is simple classification. Only one quality is here. Manifold classification has many more qualities. Just for example, firstly we have a data of population, then we bifurcate it literate and illiterate. Again we bifurcate literate and illiterate into males and females. Again we are bifurcating males and females into unmarried and married. So there are multiple layers here. So we can describe your data, or you can just bifurcate your data in manifold classification as well. Last one is quantitative data. Some data can be classified in terms of magnitude, the data on land holdings by farmers in a block. Quantitative classification is based on the land holding, which is the variable in the example. Like just for example, you can just bifurcate your land holdings in hectare. So smaller than 1, then 1 to 2, then 2 to 5, and then greater than 5. These are hectares. Then number of farmers which are holding these kind of lands. That is an example of quantitative data. Thank you.